Good afternoon, everyone. Thank you very much for joining us for this Norsepower and Maersk tanker hosted webinar. Norsepower, Maersk, Pelican, bringing sailing back to shipping, reducing fuel costs and emissions. I'm delighted to be joined by Thomas Riski, CEO of Norsepower, Thomassen, I should say, Chief Technical Officer from Maersk Tankers, Dr. Chris Craddock, Technical and Advisory and Ship Performance Manager at Lloyd's Register, and Stephen Brown, Technology, Innovation and Decarbonisation Manager at Shell. Thanks very much, gentlemen, for joining us. The primary objective of today is really to do two things. One, to take the journey that both Norsepower and Maersk Tankers undertook, and with LR and Shell very much involved in supporting, from the initiation of discussion around the installation of Norsepower's rotor sails, all the way through to the conclusion of the measurement and evaluation process, which, as many of you will already know, resulted in very strong results of an 8.2% fuel and emission saving. So that's really our purpose today. I should add that we're hoping this will take around 35 minutes, give or take. We want to encourage you to post your questions. We will have a section of the webinar towards the end devoted to filtering and asking your questions to the panelists. So with that in mind, without further ado, I'd like to turn primarily to Thomas and Tommy initially, and just ask you both how this initially came about, how that initial contact between Norsepower and Maersk Tankers happened, and how the Pelican was chosen as the vessel of choice here.
If I may start, at Norsepower, we had successfully installed two of our 18-meter rotor sails on board the ro-ro ship Estraden, and we had demonstrated that technology is working and producing considerable fuel savings. Then suddenly and luckily we were contacted by Maersk, who wanted to make a bigger trial of these kind of mechanical sails. And we then combined forces. It was a pleasure to join also Energy Technologies Institute from the UK and also Shell with this project to make this thing happen. Tommy, how do you see this from a Maersk perspective?
Yeah, pretty much the same, Thomas. We come, from a history of having tested a lot of different fuel-saving technologies initially, and thereby also CO2 emission reduction technologies. We've done that for quite some years. And we had explored wind technology from different angles and different, types of utilizing wind technologies. During the course of that, we actually quite early zoomed into Flettner rotors as being a real technology that could yield significant savings, and thereby we also scanned the market for who's out there and who was out there. The best suited technology for our type of ships, product tankers, turned out to be Norsepower, and that's where we started the dialogue and had a good initial dialogue. And then I agree, it was really great that we had the opportunity to join in the ETI and also, of course, Shell and Lloyd's in the later stages of that project. So it's really, I'd say, fitting our schedule, if you want, for what we wanted to test and try at that point of time, that we had a supplier who was reasonably well advanced in the technology side. And we had partners who were willing to step up and step in. So it was really good.
And can you just dig in a little bit to the planning? So after that initial contact, for example, I know that the rotor sails were the largest thus far that had been installed. Were there any specific challenges that you had to deal with during that sort of preparatory stage?
Yeah, obviously. I mean, it had never been done at this scale before. We're talking two 30 meter high, 5 meter diameter rotors on an existing sailing ship in actual service. So obviously we had to do a proper risk assessment, proper HAS ID workshops, considering all the operational aspects, all the different potential risky situations this could encounter into, but also of course considering all the operational performance related parameters. So there was I'd call it a thorough run up, allowing also, I believe, on your side, Thomas, the production to actually start up and time the whole thing together with us doing a lot of background work on the checks and balances.
Yeah, that's absolutely correct. For Norsepower, this was a scale-up project in big scale from 18 meter small size into 30 meters, biggest ever. And what was also first time in the world is that we fitted mechanical sails on board a tanker ship. So we had to handle all the class and other requirements of explosive environment. So it was quite fancy to do the risk analysis and all the mitigation actions in cooperation with you Maersk guys and with Shell and LR to ensure that we can meet all the regulations and make this in a safe and proper manner.
And just for our audience benefit, can you give us a rough sort of insight into the sort of the time period from that initial contact to installation?
I think we got the initial contact from Maersk in the end of 2015, and from those early dialogues it took 2 years to conclude the agreement and to start the project. But after we did that, then it went rather fast. Already in the end of August 2018 we did the fitting, and in the end of August 2019 we got the results of the trial. So it took a long time to conclude the dialogue, but then the project went pretty smoothly, I would say.
And Stephen, could you, just to bring you in here, can you tell us a little bit about Shell's involvement with this project?
Yeah, indeed. As Thomas mentioned, the ETI, Energy Technologies Institute in the UK, was involved in the project and sponsored one of the rotors. Shell, amongst others, had a stake in ETI, had invested in that research program. And ETI approached Shipping and Maritime within Shell and said, this shipping is not really our thing. We don't know so much about it. Would you help us to project manage that project on our behalf? So we were consultants to ETI with a project management oversight. I mean, of course, and to add, we wouldn't have taken on the role if we weren't super interested in the technology. So, there was mutual benefit for us to be involved.
Thanks, Stephen. And Chris, same question from an LR perspective.
Yeah, we were brought on as a trusted independent expert largely. We got involved early on with the hazard identification process to help the stakeholders identify the risks of this new technology and manage them out. And then we were brought on board through the ETI to do the independent performance assessment of this technology through measurement, essentially. So we put on data systems on board the Maersk Pelican, analysed the data before and after the float rotors were installed to give us that true underlying performance of this new technology for all stakeholders and help everyone understand how that performance comes about.
Thanks, Chris. And I want to move on to installation, because I think it will be reassuring for particularly ship owners, operators considering clean technology generally, but specifically the rotor sails, to know that process, once the commercial side was agreed, from sort of agreement there to installation, was quite a rapid one, because I think that's certainly one of the key areas. Generally, ship owners, operators want to know that this is something that is almost seamless to some degree. And Thomas and Tommy, tell us a little bit about the installation process as well, because I think that's another area where perhaps there's not that much insight as to just how it works, where the vessel was during installation and so on. If you could give us a little bit of background there, please.
So we started the installation during an ordinary docking of the ship in China at the Nantong shipyard. Aside of that ordinary 1 month docking, we fitted the foundations, cabling and automation systems on board. And during that same period, we prepared the actual rotor sail units. And the docking was in January, and in August same year, 2018, we fitted 2 rotor sail units on board the ship. So this is typically how a retrofit installation can be done. You just need to fit the foundations and cabling during docking, and then at the same time or any time after that, you can fit the rotor sails on board. Tommy, how do you see this?
Yeah, no, I completely see eye to eye on that. I think, one of the reasons why we thought this and think this technology is really interesting is because it's suited for retrofits. Once you've done your prep work in the previous docking or wherever you can do it, the actual physical installation of the rotor sails itself down in Rotterdam, and I was there, that's almost the smallest piece of the work. You do all the prep work with the cabling, the installation, the foundation, all the HAS ideas, all the work that goes into that is tremendous. And then once you plug on the rotors, that is the smallest part of it. So the physical installation of the rotors was, of course, a big event, but work-wise, it was not a big challenge. And that's what makes the technology really interesting.
Yeah, from tanker perspective, it was also interesting that we could design the foundations so that we didn't harm any coatings in those clean tanks. So it was just like welding existing foundations on the deck, actually quite easy and nice work, and then we were ready to go.
And Thomas, just quickly, from a learnings perspective, did this installation teach you much for future installations? I know that one of the ambitions you have is to continually reduce installation time, ensure that installations can also happen while the vessel's in port.
Yes, of course, it was a great learning as a project. With this ship, we did the final installation of Flettner rotors 2 pieces in 24 hours, the side of ordinary port call. So that was also a nice aspect in this one. But we have since then repeated it already a few times, so I can see that we are able to do it quite smoothly. Of course, it takes a lot of preparation and good planning, but it's doable. It was nice to demonstrate.
Thank you. So I want to move on to what is arguably the most important part of this process, the case study we're discussing today, the measurement, evaluation, and verification. I think it's clear that there are a number of technologies, energy efficiency technologies, clean technologies in the shipping industry that make very bold claims. And so ensuring that there's that obviously independent verification is vital to a technology like this. But maybe we can start a little bit earlier and just tell us about, maybe this is to you, Tommy, and Thomas again, a little bit about the sea trials and how you set that out. And Chris, you may want to come in here as well.
Yeah, so the sea trial itself, again, was well planned. And once the rotors were installed, it actually took less than a day, the actual physical sea trial of Rotterdam. And what we needed to do was, of course, to check that everything worked as it should and that the vessel maneuvering, whilst, of course, also training the crew on board on how to use the system. So we did all that in about a day's time, the actual sea trial itself.
And then it'd be really interesting, again, to bring Stephen and Chris in here, perhaps, if you could walk us all through the process of the measurement, evaluation, verification. I believe that the 8.2% was the culmination of a year of taking data. Is that right? Maybe you could walk us through that.
Yeah, for sure. So it was really important at the start of this process to understand the baseline performance of the vessel, and for any and it applies to any of the technologies. So we had to start this process before the rotors were installed and install the measurement systems on board through a baseline period of 6 months where the vessel traded around the world and we were measuring the underlying performance of that vessel, which was really important. Then we moved, once we had the rotors installed, then we continued that monitoring period for another 12 months with the rotors in operation. And the reason we did that is then we could understand what the fuel consumption of the vessel would have been if the rotors weren't installed versus when they are installed, and we can then assess the actual fuel saving for every day that those rotors were there. So that's essentially how it works, and we were continuously monitoring the performance of those rotors through that 12 months period and analysing the data and feeding back to all the stakeholders, so we can understand how the fuel savings were achieved and the conditions where we would get better fuel savings and the wind conditions that would be more favourable for the vessel.
And I guess the obvious question is here, did the eventual savings, the 8.2%, correspond with some of the expectations you had? That's to anyone.
I think
maybe I could
Thomas
address that one.
That, yeah.
At Norsepower, we have a simulation software. We can simulate any trade, and we can actually do kind of a traceback simulation, so that we take the actual wind statistics we have collected on board, and we evaluate the performance with our simulation model against the actual savings and results. And in this case, there was a perfect harmony between our simulation model and LR validation. So that was also a nice result of the project, to see that both our simulation model and LR tools work so well in harmony.
I think you go.
Yeah, thanks, Stephen. We estimated calculated the theoretical calculation showed, as we said, in the range of 7 to 10%. So the savings we achieved here, a good 8%, was definitely within that range and as expected. And obviously, when you set the bar high, then it's difficult not to get disappointed normally. But in this case, we feel that the technology yielded the savings over the test period that we expected.
Stephen, please come in.
Yeah, no, I think it's also fair to say that this was a trial, and there is naturally some teething troubles, which we experienced and overcame very quickly with everyone's support and effort. But also we found that actually the ship was still a trading ship, and it wasn't actually on the most favourable of routes all of the time, including the teething troubles, and then also the fact that the wind speeds for that particular year of performance monitoring were actually lower than average. So the reality is the 8.2 is excellent. Really, we were all really pleased with that outcome, but in reality, it's potentially more.
And could you just remind the audience where the majority of the Pelican sailing time was during that year, and indeed it'd be great just to understand what the savings might have been, say, transatlantic route, which we know is favourable.
I think the route's probably one for Tommy, and then the latter question more for Thomas.
Sounds good.
Yeah, so on the first one, we started coming out of the yard. We started, coming out with the rotors. We started going towards Asia, and the ship sailed quite a bit north-south journeys out in Far East Asia, which is far from optimal from a wind perspective. So we had a dialogue with our charterers and the commercial partner here, and we had the ship more on longer transatlantic voyages, or transocean voyages from there on. So that definitely helped afterwards. And then over to Thomas.
Yes, thank you. The same simulation model, which was in perfect harmony with the results of this project, is telling that a ship like Maersk Pelican would save around roughly 20% in average on Northern Atlantic crossing, doing like Rotterdam, New York all the time, or that kind of trade. So that's quite interesting. Looking forward to see the first ship sailing that route with our technology.
And just one more while we're on the sort of measurement evaluation piece. So what percentage of, if you have this figure, what percentage of time was the rotor sail utilized during those periods?
Well, we were Chris recalls that figure, but I think it was around 50%, at least, not more, even less, because of the quite weak winds on some of the route areas.
Yeah, and it did increase as we went through the trial slightly. So it did start off around 40 and then got to sort of 55% utilization by the end of it. But it's I think as Thomas will point out, there is a automation system on board which will decide whether to turn the rotors on or off depending on the favourable wind conditions as well. So that also plays into it as well.
Thanks, Chris. And then the million-dollar question, I guess, here is sort of the payback period. So I guess if we assume, typical commercial dynamics, what sort of, based on the savings that the Pelican achieved, what sort of payback period would we be expecting to see for that vessel type? I guess that's to you, Thomas.
Yeah, thanks. When I again look at our simulation model, the results of this project, typical trading profiles of tankers and let's say long-term typical fuel prices, let's say the level they used to be like 1 year ago, I can see that tankers trading on different areas have roughly 4 to 9 year payback with this kind of technology.
Thank you. Thanks, guys. So I want to broaden it slightly.
Can I add to that, Adam? Can I add to that?
Tommy. Yes, of course.
I just want to say that the current fuel price doesn't help a lot on the payback time. So obviously, the higher the fuel price, the better payback times. But it's also important to say that that's not the only reason why at least we are in there. This is hugely important in saving CO2. We want to participate and drive the CO2 saving agenda, and we believe that this particular technology has a huge potential in that, probably one of the biggest retrofit potentials we can see out there, and that's why we're doing it also. So it's not only a payback calculation that drives us to it.
Yep, very good point to make. So we're starting to see a few questions come through, and I do want to turn to the sort of bigger picture, but maybe as a segue to that, just to reference a couple of points. And one is that obviously the vessel, or rather a vessel with the rotor sails installed, ultimately will benefit more in favorable wind conditions. And someone here is suggesting that maybe that means that a vessel will become inflexible for other trading routes on the spot market. How would you respond to that? And I guess that's arguably to Thomas and Tommy, but anyone please come in.
Yeah, so I can start off. As part of the pre-screenings we did before going ahead with this project, we actually also were in dialogue with different customers out there, and had a dialogue with some of those customers about what is the potential trading impact, if any, of bringing about to the market a ship with two tall towers that are rotating. Neither in the pre-checks nor afterwards in service have we had any complaints or lost opportunities because of having Flettner rotors on board. So we haven't seen any negative impact. On the contrary, this being again a test and having been quite visible in the industry, has actually brought some, I'd call it, positive attention also to this particular vessel with the rotors. And I've not seen one single spot voyage we had to turn on. And I know the LR2s are not typically on that many different routes. It might be difficult for smaller ship types on spot, but for the larger ships, this is not, in my view, a big issue.
Thanks for that. Thomas, anything to add?
Yeah, I completely agree on that one. With our rotor cells fitted, Maersk Pelican could still enter all major oil terminals in the world and make the ordinary trade. And also, aside of the project, Shell conducted a survey on different oil terminals and operators, and we didn't find absolutely any constraints because of rotor cells.
Thank you. Another question has come through. Do the rotor sails tilt down to get under bridges and therefore not increase the vessel's air draft?
That's a very good question, especially today. When establishing Norsepower, I all the time had a vision that one day we might bring to the market a tilting rotor sail model. We hadn't needed it so far. Maersk Pelican was fine with upright all the time rotor sails, but now we have developed that design, and we are actually quite soon launching a press release of the first ship to be fitted with tilting rotor sails. So in a way, in our new tilt option, there's a hinge, between the rotor sail foundation and the rotor sail, so that you can tilt it down on temporary basis to pass under bridges. I think that's a nice added feature to working product.
And just quickly, while I've got you there, Thomas, and probably to Tommy as well, and then I want to bring Chris and Stephen back in. Maintenance, how much time does the system require, I say, a per week basis from the crew, or indeed onshore support?
Of course, with first prototypes, there are some hiccups and more maintenance needs, but we can now already see that when we get stabilized our delivered installations, we can reach that biannual maintenance interval, which is our target. So it's typically enough if the devices are checked 2 times per year, and our current estimation of the long-term maintenance needs, it's about 1 man day per device per 6 months, and it's doable by the crew also. Norsepower typically delivers the spare parts if needed.
Tommy, anything to add there?
Yeah, so again, prototypes are different from ordinary production designs, obviously. So we had a few teething problems, but that's exactly why we do the test also, to take those learnings and build them into future designs, if you want. I think I echo what Thomas said here, that generally these things are pretty simple. They're pretty simple to operate, and they're pretty simple to maintain also, which is also part of the attractiveness of this particular technology.
Thank you.
And it was also a nice finding that this part of the prototype aspect of this project, we could reach that more than 8% net average savings over the entire period, also including any teething fixes or so on.
Yeah, echo that. Yeah.
Thank you. Chris, I want to bring you in, because obviously in your role at LR, you see presumably a whole spectrum of energy efficiency technologies, clean technology that is being applied, or that is certainly has the ambition to be applied to vessels in the international fleet. I'm curious as to how you envisage the sort of the role rotor sails can play in reaching shipping decarbonisation goals.
They will play a role. They won't. Any technology such as this or any energy-saving device won't be the full solution to solve the decarbonisation problems that we have. But this technology is clearly shown that it can be part of the solution, as many other technologies are out there. I think it was really interesting to see this technology. Most of the energy-saving devices we see on ships today are in the realm of 1%, 2%, 3% savings. But when you start getting up over 5%, it becomes a really interesting technology. So this is, because it's got such a high benefit, it will probably play a strong part going into the future in the decarbonisation. We still obviously need to look at alternative fuels as well. That's going to be really important, but it won't be just alternative fuels. We need to reduce the powering requirement of these ships, and Flettner rotors is a potential solution to do that as well. So it's a collection of different technologies which will solve the decarbonisation problem, and Flettner rotors are one of those technologies that can help.
Do you think to some degree there's an element where we're maybe collectively guilty of being a little bit distracted by zero or very low carbon fuels and energy, and missing the fact that there are technologies like the rotor sails that, you know, what we're discussing here have the potential to get to maybe 20%?
I think we need to look at this as a maturity of technologies as well. Today, we're talking about Flettner rotors that are reaching that stage where it is technology mature and we can start putting them on ships. The alternative fuels development has still got a road to go. We can't lose sight of that, and we still need to push towards that, because as I said, we can't, even though there's potential scope to reduce the emissions by 20% with these Flettner rotors, we won't get what we're after with the 80% reduction of carbon emissions that we're looking for with the IMO goals, and total 50% over the whole fleet. So that we won't be able to do that with just wind power, but it will help for sure.
Any other comments on that? Stephen, any thoughts there?
Yeah, I would sort of echo a lot of Chris's comments. I mean, our work within Shell around decarbonisation suggests or concludes that all decarbonisation pathways rely heavily on energy efficient technology. And that, we don't know which fuel will emerge yet. There's a few front runners today, but each of them are challenged in some way. And one of the key challenges is energy density, which means we have to start using a lot more of the hull for the fuel if we want the same range. If we can reduce fuel consumption in the first instance, we offset that a little bit, and it helps. So absolutely essential that these technologies are adopted and become standard outfitting on vessels of the future.
Thanks, Stephen. I guess this is one for you, Tommy.
Can I?
Sorry, beg your pardon. Please go.
And again, coming from the decarbonisation or CO2 angle to things, as I said, we believe that this particular technology has more potential than other current technologies out there, which is what makes it interesting also for retrofit, and obviously once we get to that for new buildings. But there's a timing issue. Chris mentioned that there will be a long runway for alternative fuels to maybe be available. The trick with this particular technology is that it's already available. So together with other technologies, whether it's high efficiency anti-foulings or engine gadgets, or in this case,
I think we might have lost Tommy. Can you still hear me, guys?
Yes.
Yeah.
Okay, we can come back to Tommy. But just on that, Thomas, do you have any quick thoughts about the role for rotor sails?
As Tommy mentioned, I think we can play a role in reducing the energy consumption of ships. We can't resolve the entire industry's decarbonisation alone with rotor sails, but we can make quite a nice contribution. We have actually analysed the entire fleet. We used some AIS data and existing operational profiles of ships, and we imagined a world where we fit 25,000 feasible ship-type ships without rotor sails. And we concluded that based on the results of the Maersk Pelican project, we could reduce the global CO2 emissions of shipping with roughly 70 megatons per year. So that's about 7% of the entire total global emissions of shipping. It would mean that the savings would be bigger as in the case of Maersk Pelican because of more rotor sails fitted, but as a figure it's quite impressive one. So we can see that that's feasible with today's technology. Quite a nice contribution for the decarbonisation.
Thanks, Thomas. And Tommy, we got you back. We cut you, or you were cut off mid-sentence. I think you're on mute. Oh, there you go.
Are you okay? Technology issues. Can you hear me?
Yes, that's great.
Yes.
Okay.
Better now.
I'm on mute, but I can at least speak. So, and sorry about the technology issues. That's almost like Microsoft. But So the trick is that it will be a host of different technology solutions that will be put in play here short, medium term, in order for us to really make progress on reducing CO2. And we want to make progress on CO2. We want to partake in driving the industry, and not only the tanker industry, but the shipping industry, in reducing CO2 emissions. So also being vocal around these things really has the biggest of our attentions, even in the current point of time. It's great to see that others are joining. I noticed that a couple of the ferry companies here around Northwest Europe are also joining forces now, and it's really good to see that it starts picking up. So there are more people coming into this game. But we want to do all of this while we also, of course, want to focus on the actual operation, and doing so by applying also digital solution in the way we optimize our operation of the ships day to day, and maybe at a certain point of time integrate the technology hardware solutions with the digital solutions, being better at both operating the ships, making sure that we benefit from large scale. We have a lot of ships under our management, and while we do that, test off new technologies, help develop new solutions for the future also. That's a big part of our agenda.
Yeah, thank you, Tommy. And obviously, Maersk have more ambitious targets than the IMO in terms of their 2050 decarbonisation objectives and goals. And the last question, I guess, really is, Tommy, what are your plans, if you can reveal as such, for rotor sales at Maersk Tankers?
Now I'll try this again, and the way it works is I unmute and then I mute my speaker, but it works okay. So right now the trick, of course, is to make sure that there are rotors out there that are off the shelf ready to go, more or less. And as you know, both Norsepower and we are working closely together in trying to push that in order to have them available as soon as possible. And then the trick, of course, as you pointed out, we need to make this a commercially viable product also together. And we are working on that jointly too, both on the way we do the actual physical installation, but also the rotors themselves. And one way of doing this is to push for more volume, and I'm sure Thomas would like that. So we are working with the industry through different industry organs also to try and show what the technology is capable of, and get some more people join the bandwagon, if you want, come on board and do some new installations with us. That'll be good.
Thank you, Tommy, and thank you to all the panelists. It's been really helpful, I'm sure, for the audience to understand a little bit of detail around the journey, in this case, resulting in those fantastic savings and that extra insight. The webinar will be available to watch at any time on the Norsepower website, so I'm sure it'll be up there in the next day or two. And yes, thank you once again to Chris and Stephen, Tommy and Thomas. Thomas, we'll let you go back to your sailing boat now. Thanks for your time and thanks for joining.
Thank you.
Thanks. Bye-bye.
Thank you.